So for this one, we'd get 2 sine theta equals 1, and then sine theta equals a half. Now that's where sine equals a half, and sine equals a half where y equals a half, correct? And where is y positive? Quadrants 1 and 2. So we're going to look for quadrants 1 and 2. I'm going to look where y is a half, which is here and here. So it's going to be 30 and 150. Okay. 2, we have tan squared theta minus 1 equals 0. Then we're going to get tan squared theta, and we're going to add the 1 over, so we're going to get equals 1. Then we take the square root, and we take the square root, we get plus or minus. And so we get tan theta equals plus or minus 1. Now, tan is sine divided by cos, or y divided by x, because it's tan your x box. So, when we have that, the only places where our x's and y's are the same are at 45s, correct? If you look at your 45-degree reference angles, it's root 2 over 2 and root 2 over 2, or root 2 over 2 and negative root 2 over 2, which would make it be negative 1. So in this quadrant, we have root 2 over 2 and root 2 over 2. So tan theta would equal 1. In this quadrant, our y is root 2 over 2, but our x is negative root 2 over 2. So when you divide them, your tan theta would be negative 1. In this quadrant at 45, yours are negative root 2 over 2 divided by negative root 2 over 2, which makes it actually be 1. And then here, we're going to have negative root 2 over 2 divided by positive root 2 over 2, which is negative 1. So, we need all of those because we need plus or minus 1. If we only needed positive 1, we would state, if we only needed positive 1, we would state 45 and 225. If we only needed negatives, we'd state 135 and 315, correct? But we need all of them. So this one's at 225, this one's at 135, this is at 315. So we'll say theta equals 45, 135, 225, and 315. So that's if I'm asking for the angle and I give you the answer on the outside. Then the other thing I can ask you for on the test is I give you the angle and I ask you for the answer. Sine 390 is too big, correct? So what am I going to have to do to get the answer? Subtract 360. So if I go 390, subtract 360, I get 30. Now sine is what? The x or the y? It's the y. So when I go to sine, when I go to 30, I pick off the y. What's the answer? At 30, what's your y? 1/2. Done. Cos negative 120 is too small, correct? So I'm not going to subtract 360, I'm going to add 360. And so I get cos of 240. So I go to 240, and cos is the x or the y? Cos is the x. And what's the x at 240? Because it's Calgary Stampede. What's the x at 240? Negative 1/2. Tan 90, negative 90, if I add 360 to it, I get tan 270. Tan, on your formula sheet, tan is the same as sine of 270 divided by cos of 270. What is the y of 270? Anyone know? Go look for 270 on your unit circle. Everyone's looking at it. What is sine at 270? What is the y at 270? Negative 1. And what's the cos of 270? What is the x at 270? 0. What happens when I divide by 0? Undefined. So those are the basic trig ones that I'm going to ask you for this test. We're going to move more on to trig at the very end just to extend, but it won't be on your final or on your unit test, but it's to learn more about trig before we move to 30.
Is this the last unit?
Reciprocals and absolutes, yes, are what we'll be starting on. Then we're advancing on to, we're going to extend on trig and we're going to extend on transformations.
For next year.
Yeah.
And so our unit test is going to say number along in the final.
Correct.
Well, actually.
For the last piece? Yeah. For reciprocals and absolutes, yes. And you're having another cumulative before the final too.
Yeah, so how does that doesn't make sense.
What else is on this unit test? Starts with an R. Rationals. Okay, so we're going to do a simplify. Simplify is the entire test except for solving. Simply. Perfect. Perfect. You're done. You're basic. That's what I feel like I am right now. Simplify. Okay. So simplify covers simplifying, which is just a plain old rational, one numerator, one denominator, correct? It also can be used as the directing words for multiplying. How do we know we multiply? Has a multiplication symbol. Okay, then it can be used for division. How do we know we divide? Division symbol. And then adding and subtracting, how do we know? Adding and subtraction. Yes, yes. And then at the end we have solving, and you'll have a word problem. Remember that? It's real. Okay. We will be doing those too.
Yeah.
Oh, okay. Sure.
Just delete them.
No problem. Why not? You know? When the going gets tough, we just take it off the table. Yeah. Cool. Cool, cool, cool. Yeah, that ain't happening. Okay. 27a squared b cubed over 4ax cubed divided by... So much whining. 9a 4b squared shush 2 x 2y squared. Shh. A. So you're doing these ones. The first one, A, is a monomial. So monomials, you just state the NPVs as can equal 0, and then cross off ones that match after you flipped it. There are no plus or minus signs, right? All right. So the first one is a monomial and a monomial. Now what I told you when you have monomials is you could actually put every single term in its own brackets if you wanted to. You could go negative 27, a squared, b cubed, because they're all multiplied, over 4, a, x cubed, times 2, x squared, y squared. Look at the y, but I'm not redoing it. 9, a4, b squared. Okay, so what we want to do is, whenever we have a multiplication, remember we can just draw a straight numerator over numerator, denominator over denominator. When they're all monomials, anything that was in the numerator or in the denominator gets counted, so everything but the top left is division. But when they're monomials, every letter that's by itself just can't equal 0. So we have an A, X, X, Y, A, and B. So our NPVs are going to be A, comma B, comma X, comma Y, can't equal 0. Then we can cancel off anything that matches. So I have an X squared and an X cubed. So I'm going to cross the X squared off, and this cubed is going to become a 1. B squared goes completely away, and then 2 of these B's, so it's B1. A squared cancels off 2 of these, so I get A squared. Then I can take 2 out of the 4 and the 2. So the 2 completely cancels off. 4 divided by 2 is 2. 27 and 9, I can take out a 9. Negative 27 divided by 9 is negative 3. 9 divided by 9 is a 1. And so I'm going to get negative 3 on the top, b, y squared, over 2 times 1, which is 2. And what's a times a squared? A to the triple. Sure. A to the 3. And then a, b, x, y can't equal 0. Okay. When they're not what?
That was the other way of saying it. You don't know.
What is what?
The other way of saying
A cubed.
cubed.
So when we multiply or divide rationals, and they're not monomials, our first step is to Gcf difference of squares factor all the numerators, all the denominators, correct? So when you multiply and divide, it's Gcf factor difference of squares, all the numerators, all the denominators. So this one is a multiplication. So the top left, I can take out a 6, and then I'm left with 5 minus x. And I have an equal sign running down the left-hand side because it's not a solving one. Yep.
You gotta put an X in the answer.
Good call. Then, the bottom left, we factor it. Well, multiplies to give us 10 and adds to give us negative 7. It's x minus 5, x minus 2. And the 3x squared minus 5x minus 2, I have to factor by decomp. So what multiplies give me negative 6 and adds give me negative 5. Negative 6, positive 1. You can take a 3x out, we're left with x minus 2. We go to plus 1, and we're left with x minus 2. So we get 3x plus 1, x minus 2. And I told you, if you're sitting there staring and you're like, nothing cancels, something is wrong, most often it is difference of squares that you're missing, right? So x squared minus 25. The square root of x squared is x in front of each bracket. The square root of 25 is 5 at the back of each bracket, plus or minus. Now, because it's a multiplication, we can do a full numerator or a full denominator. Before we go to cancel anything off, though, what should we do? NPVs. So we have x can't equal 5 from the x minus 5, 2 from the x minus 2, negative 1/3 from the 3x plus 1, 2 again, 5 again, and then negative 5. So I'm going to go plus or minus 5 in front of the 5. Now we'll see what we can cancel. What?
Why do you?
Just the bottom?
Yeah. You didn't
Oh
divide.
wow, I really want to do division. But it's not. I'm glad you're so happy, Nick. Okay. First time he's paid attention all year. All right.
Hey!
But after all.
No! Yeah!
All right. That backfired. Okay. X minus 2 cancels. Now some people will tell me 5 minus x is the same as x minus 5. Is it?
No, they're
No.
wrong.
What do they have to do?
They have to take a negative one out.
Yeah, so I should have taken out a negative 6. Then this would be negative 5 and positive x. And then they would actually cancel. So on the top I'm left with negative 6, 3x plus 1.
Oh,
And on the bottom, I'm left with x minus 5x plus 5. X can't equal plus or minus 5 and 2.
wait. Yeah, that's pretty good.
So with multiplication and division and just to basic simplify everything over denominator, your first step always is to Gcf difference of squares or factor all the numerators, all the denominators. But with adding, subtracting, and solving, what's your first step?
Factor the
And only the, right. If you can factor the numerators, you don't. You just factor the denominators. So we're going to get an equal sign running down the left because these are not solvings. So we get 6 over, what multiplies give me 24, and that's give me 11. Y plus 3, y plus 8. Minus 3y over y plus 8. So our first step when adding, subtracting, and solving is to Gcf different squares or factor the denominators. And what's our second step always? Point proving why the window has to be closed. Okay. So, what's our next step with adding and subtracting? Yeah.
You're like, put the y plus 3.
On the right hand side. Yeah. This means to make common denominators. So we go y plus 3, y plus 3. And then we distribute. But we only distribute the what? What do we only distribute?
The top.
The top, the numerators. So we're going to get 6 over y plus 3, y plus 8 minus 3y squared plus 9y over y plus 3, y plus 8. So our first step is Gcf difference of squares or factor the denominators. Second step is to make a common denominator. Third step is to distribute. And then fourth step is to write over one denominator, correct? So we're going to get y plus 3, y plus 8. And on the top we get 6. And with subtraction we have to remember to distribute that minus sign through. So we get minus 3y squared plus 9y. Can we collect any like terms? We can't take anything out. We can try and take, we can't cancel anything off. We can't collect any like terms. But we can try and take a 3y out of the, I'm going to take a negative 3 out. And then I'm going to be left with y squared minus 3y minus 2. And I can't factor that at all. So I just state my MPVs.
What would be a plus 3y?
No.
Negative.
I took a negative 3 out.
The 9 is above the
negative.
Oh, good golly, Miss Molly. Oh, I said to distribute, then didn't.
I didn't make
I think that is a terrible.
I can dig the teacher for
Yeah, can we do that?
No.
That'd be so fun.
Like last day class.
That would be so fun. So the final review, just like,
Get every question involved.
that's the system. Alright, for your final exam, you'll be driving.
Nick has trouble talking. Okay, why would I put D up here?
It's ruined now.
Why would I put D up here?
Because we have to do
The
cross
times.
multiply. Like cross
Times
times
binomial?
Times are by each other, because one's a monomial and one's a binomial. And I set you up because people think they can just multiply by negative 2 and make the right hand side the same. But then it would be negative 2x, not x minus 2. So you have to multiply them by each other. Do we distribute the denominators?
Never.
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 So we get x squared plus 3x in the numerator over x minus 2
What is David doing up there?
plus 4x squared minus 8x plus 1x. Shh. Stop talking. So when we have a plus sign, it's not as much to remember. Guys, stop talking. I'm not reviewing for myself. X squared plus 3x plus 4x squared minus 8x plus 1x minus 2. And we collect like terms. X squared plus 4x squared is 5x squared 3x plus 1x is 4x minus 8x is negative 4x, and then minus 2. So anything multiply, give me negative 10, and that give me negative 4. What?
Last one question.
Yeah, what?
Oh, so if like, in the end, if like a fraction looks so weird, can you like, say x is like 2, and then plug it into both equations and see if it goes? Like the original?
You can put, yep,
Okay,
whenever it's a simplified.
yeah.
Yeah, you can always put like 3 or 2 in
Okay.
to both of them and see if you get the same answer.
Oh, see?
And then you like go through your steps to see.
Yep.
the next-
So if someone errors, if they say, where did Sam make an error? You can plug a 2 and plug a 2 and plug a 2 until
Yeah.
it doesn't match. Yep. All right. Solving. Here's 2 solves, then we're doing a word problem, then we're reminding ourselves about reciprocals because we're going to, hopefully.
Oh.
If not, this is our review. Anyways.
Where's the pen? Yeah.
That is,
Hey, she owns us. I didn't even know it. We can't even do it.
Free country.
All right, so when it's adding, subtracting, or solving, the first thing we do is Gcf difference of squares, only the denominators. Everything else, numerators and denominators. But adding, subtracting, and solving, only denominators. So this one is going to be 2x minus 6. Some people run equal signs down the left. You don't. There's one right here. We only need one per question. Okay, so plus 7 over x plus 2 equals 4x plus 2 over x minus 6, x plus 2. Which you should be very happy when that happens because they match these two. If they don't, go back, you factored wrong because they always match those two. I'm not that mean. Okay, so we have to multiply this one by x plus 2. And this one by x minus 6. And so on the top we distribute, but the bottom, do we ever distribute when it's adding, subtracting, or solving?
Never.
Never. So we're going to get 2x plus 4 over x minus 6x plus 2 plus 7x minus 42 over x minus 6x plus 2 equals 4x plus 2 over x minus 6x plus 2. Now the left-hand side we put together just as if it was an addition. So we have a common denominator we can put together. X minus 6, x plus 2. So we get 2x plus 4 plus 7x minus 42 equals 4x plus 2.
What's funny?
there's a fight.
So we get 9x minus 38 over x minus 6x plus 2. Now if you get one of these, you should be very happy because there's no squares. I got sidetracked. Now, when our denominators equal, we can set our numerators equal. But before we set our numerators equal, we should do what? Before we set our numerators equal and drop off our denominators, what should we do? Thank you. So our NPVs are x can't equal 6 and negative 2. So we get 9x minus 38 equals 4x plus 2. Minus 4x. 5x minus 38 equals 2. Add 38. 5x equals 40. Divide by 5. X equals 8. And then we follow behind with x can't equal 6 and negative 2. So is our solution one of our NPVs? No, so it's good. If our solution is one of our NPVs, we circle it, put a line through it, and say extraneous. Just like we did with radicals. Okay, this one, we have to factor the denominator on the right, because we Gcf difference of squares or factor all of our denominators when it's adding, subtracting, or solving. So this stays the same, 4k plus 1 over k plus 2 minus k plus 1 over k minus 2. equals k squared minus 4k plus 24 over k plus 1, or k plus 2, k minus 2. That's the difference of squares. So the first one and the second one are missing stuff. This one's missing k minus 2. And this is missing k plus 2. Now we distribute our numerators. Can we distribute our denominators? Never. So we're going to get 4k squared minus 8k plus 1 minus 8k plus 1k minus 2 all over k plus 2k minus 2 minus k squared plus 2k plus 1k plus 2 all over k plus 2 k minus 2 equals k squared minus 4k plus 24 k minus 2k plus 2. Now the left-hand side has a common denominator. Yo, what is it?
You did 4k plus 1, but it was 4k minus 1.
Oh, that's disappointing.
You're going to have to erase that.
Not, 'tis not true. Okay, so on your written response on your test, you'll end up with one of these, just so you know.
Like, does it have to have k in it?
I'll put X's.
Thank you.
Thank you, appreciate that.
Appreciate it.
It's
You're
just one
welcome.
more line.
It's a gift. Okay, k plus 2, k minus 2. What's the matter?
Like, even Y's.
What's the matter?
I don't know, Tegan's saying something.
Tegan's still upset. What's the matter, Tegan?
Don't cry.
I'm just an idiot.
Tegan, don't cry.
You are not an idiot, Tegan.
I'm looking at my sheet, it says idiot.
All right, k minus 1, 8k minus 1k plus 2. And then we have to remember to minus everything behind the minus sign. So minus k squared minus 2k minus 1k minus 2. K squared minus 4k plus 24. K minus 2k plus 2. So when we collect like terms on this side, we get 3k squared minus 8k minus 9k minus 11k minus 12k. And the 2's cancel. Equals k squared minus 4k plus 24. And the denominators, I'm going to cancel off, but I have to say k can't equal plus or minus 2 first. Now, when I have squares, what do I have to do? Move everything to one side and set equal to 0, right? Or I can't use the quadratic formula. So I'm going to subtract k squared, add 4k, subtract 24, subtract k squared, add 4k, subtract 24. And I get 2k squared minus 8k minus 24 equals 0. I can reduce it down, or I can just go A equals 2, B equals negative 8, C equals negative 24. Or I could take a 2 out, and A would equal 1, B would equal negative 4, C would equal negative 12. You'll still get the same answer. So we'll get X equals negative and negative 8, plus or minus the square root of negative 8 squared minus 4 times 2 times negative 24. All over 2 times 2. I don't know what that is. $256. Oh, you could have factored this one. It's 256 is a perfect square. 16.
Oh, the
You could have factored it 8 plus 16 over 4. X equals 8 minus 16 over 4. This one's 24 over 4, 6. And this one is 8 over 4, negative 2. What's the problem with my answers? X equals 6 is good. X equals negative 2 is extraneous. It's one of the non-permissible values.
Well, that is a risky little drive.
On his,
Imagine trying to merge on the cloud on
his
his
mom.
How do you spell moped?
It's moped.
How do you spell moped?
Moped.
Isn't that how you spell moped?
Yep.
Okay.
Rachel, when you would know.
I was a moped rider.
Is that how you spell moped?
Yeah, that's right, yeah.
Christian also.
Okay, get over the moped part. Just write something down here. Okay. Ted drives to Calgary on his moped. It is 36 kilometers to get there. It takes, this is terrible English, but whatever.
Oh, it's one of these.
Tom
Hello, did he walk?
drives
No.
to Calgary
Okay.
in his motorhome.
That's a hot one. That's a
It is also 36 kilometers away.
Why would motorhome?
That's all he's got. Stop it. Don't cut down Tom, okay? Tom drives 35 kilometers per hour faster than Ted.
There's no middle class family in motorhome.
Tom takes 10 minutes less. Determine the time of Tom. Okay, so whenever we get one of these, we have to set up our table, remembering that there will always, yep. I need paper. Have you not learned? You send the guy on a long weekend and he forgets his manners again, then he learns. Send the guy on a long weekend and he forgets his manners. Oh, you're okay. Okay. All right. Okay, so we have distance, speed, time, Ted and Tom. What do we know? We know the distance, which is 36 kilometers. 10 minutes is how much of an hour? We're going to pick something that's not going to give us an ugly decimal. Let's do 12 minutes less.
Well,
Because that is 0.2 hours. 10 would have given us, around like a non-terminating decimal. So we had to use a fraction. I feel like doing that. Okay. So the speed of Tom is faster than Ted by what? And it has to be in hours because the speed's in hours. This time has to be in hours. So Tom drives 35 kilometers per hour faster than Ted. So Ted is X, then Tom is X plus 35 because he does 35 kilometers per hour faster. Not 35 times faster. That's insane. That motor will be flying.
Dolphins aren't very fast.
Yeah, but they can go 60.
Can somebody go 70?
Tom will be flying. Ooh. Slow it down. Okay. We're missing the t's. Often we're missing the t's. Remember we used the distance, speed, time triangle, which is alphabetical order. Cover up the t. It's distance divided by speed. If you don't know where the x, if it should go on the top or the bottom, you're in the rationals unit. Where do the x's go on a rational? The bottom. So if you're stuck, at the very least, put the x's on the bottom, or else we're not in this unit. So it's 36 divided by x, 36 divided by x plus 35, and we'll finish
I need to
it
know.
tomorrow. You guys try it out.